in this video, I explain a question regarding internal energy change. We know there are two forms, right? Heat and work, okay? And then how that type of question we can ask you, or in the sense of what kind of questions you can run into, okay? So just give you an example question. I'm gonna start to share my screen and then let's look into it. Okay, so for this question, this is a type of question I told you in the lecture, typical question I need you to know. Okay, so delta E of the system, and then you go delta E. I know what delta E equals to. That's first thing first, we should have clear idea about, right? Heat plus work. Okay, so there are two forms, right, for convert and right, so convert energy, heat or work. Okay, and then heat and work. So a system is absorbing that much heat. So then that means the heat is positive. Okay, how much? 35.8 kilojoule. Okay, so then let's put that information in. So positive 35.8 kilojoule. Okay, so that's for that. And then what about work? Okay, so let's see. Do we know some information about work? Okay, so it's saying it's expanding from 8 to 24 liter in volume at 1 ATM. Okay, so you go, okay, I don't get the information for work, but can I calculate work? And know volume change and know ATM, which is a pressure. Okay, so that's pressure units. Okay, so you go, oh, it's talking about gas. Okay, so gas, I know, right? Pressure is an important property. So then work equals negative P delta V. So I can use that equation to help me. Okay, so then work equals to negative is 1 ATM times temperature change should be final minus initial. Okay, so then I get my numbers. So this come out as negative 16 ATM times liter. Okay, so you go, oh, what kind of units is this, right? I'm looking for work, should be either on joule or kilojoule, but this is not. But then that's also why we notice there's a conversion factor given. Okay, so that'll be given as well during the exam. So then you can use that to convert the units. Okay, so then I go, okay, so that's easy. So 1 liter times ATM is 101.3 joules. That cancels out. Okay, so then I get the number right of number will be negative 1620.8 joules. Okay, so now you, okay, I got the work. So let me plug that in. Okay, so that's what I have. Then it's negative 16220.8 joules. You go, oh, now I just put into my calculator. You go, no, right? So I have a joule, kilojoule. They're not on the same scale, right? I have to take care of that. Okay, so then I need to convert that joule to kilojoule. That's also another easy job. We know 1,000 joule equals to 1 kilojoule. So this will be negative 1.6208 kilojoule. Now we can put it back in here and then do the calculation, right? So now that turns out to be negative 1.6208 kilojoule. Now both of them on kilojoule, I can simply do the calculation. So delta E, the internal energy change, and will equals to positive 34.2 kilojoule. Okay, so then that's the answer. Nice and easy question, but again, you just need to pay attention to a few details. But other than that, it should be straightforward. Okay, so and then thank you for listening, and hopefully this is helpful.